Well, thank you for joining the session. I'm Michael Meiner from German Aerospace Center, and I'm going to talk about automatic assessment of software quality with Hermes. I'll come to the quality in a minute. But first, a few words about me. I'm working at the German Aerospace Center in Berlin. I'm board member of the German DERSE Society, and I'm core developer of the Hermes tool, which was kind of kicking off the talk which I'm going to present. And yeah, maybe one of you heard about the Hermes. I will have a slide later on. But the Hermes project, we realized it's a tool which is really helpful, and then we started to going to some kind of loose consortium to continue developing. So our project stopped. We finished with our funded project, and we needed to continue it because we think it's really important. Yeah, and it's open for collaborations. You can look at it, you can use it, and you can get in contact with us. And the problem I'm talking about is that already, software is important for research. This is why we are all here, I think. And the nice thing is the funders are kind of understood that it's important not to only fund the research output, but also to put some funding grants for software, and more funding grants states that software development should be in a good quality and stuff like this. But the agencies want to check this, so they need some kind of return on investment for the software quality that they step in. And this is the question: how should they do this without some KPIs, some key performance indicators, or some numbers which you can present to managers so that they see how good the software is? And this is especially true for the Hermes Association, which is a big German scientific consortium giving grants out, lots of grants for lots of centers. And they started to say, okay, we want to fund software, but we also want to have KPIs to see how good this software is that we funded. And they started a task group which works on these KPIs for software. And the core of this all is kind of more not looking at the software. So that's not what I'm talking about. I'm not talking about today about cyclomatic complexity, code coverage, or stuff like this, but on the notion of quality that the funders have. And they don't want to see complex technical terms. They want really to see, okay, how good is the software developed? And so they are more looking on development processes and lifecycle management issues here. And this is the quality indicators I'm looking into in my talk. And as a base for this, there is an Hermes Vision paper, which has been published on arXiv already in the second version. And this is also the core for my talk. I'm looking into the indicators here. The paper is still up, but it has made good progress. So what you can read in the paper is still valid, but we are a step further. So some of the criteria are sharpened, but I will go through this in a minute. And my outline is, first I'll introduce you to the tools I'm using here. So one is a COBIT maturity model, and the other is a Hermes workflow. I will explain shortly. Then I'll take a dive into the indicators that we currently have, looking at some examples how these indicators could automatically be assessed, and maybe what could be improved to make them accessible. And then I'll end with an outlook. So first thing I already mentioned, this software indicators is based on the COBIT maturity model. COBIT is from design a framework for IT management and government, but it brings this maturity model with it. And this maturity model looks or tried to measure how advanced the process is, how sustainable the process is, how good the quality of the outputs of this process will be. And therefore there are 5 levels, or exactly there are 6 levels. There is also a level 0, which means not implemented at all. Then is the first level, which says, okay, there is some initial information, so at least people kind of have some idea, an ad hoc idea how stuff should be done. Second is then this process should be repeatable, so it's not only a once process, but some knowledge is available to repeat this process. Third one is the process should be well defined, so you really have a document or something which states, okay, this is the process you have to follow. The fourth thing is then the management of the process. So not only stating this is the process you have to follow, but enforcing the process and looking whether the process is really done as it is prescribed. And the last level is then a process that is being monitored and optimized. So it's not only seeing whether the process is done, but also where the drawbacks of the process are, where weaknesses are, and countering them. So this is a basic model which we use for our quality indicators in general. And the next one is Hermes. Hermes is a tool that we developed during the last 3 years to help scientists publish their software with rich metadata. And yeah, software always has some metadata. Mostly it's hidden somewhere and not explicited. And with Hermes, we collect all this metadata into a common format and then provide a tool that also allows to publish this software with the metadata in it. And where is the connection between metadata and the process? This is kind of my talk here. But I think that software quality is just another metadatum for software. So that's why we thought, okay, let's look whether Hermes can be leveraged to also monitor these KPIs and software quality stuff. And last but not least, we have, or the paper identifies 6 dimensions which are important for good research software. And these are the 4 well-known FAIR4RS criteria. So it should be findable, it should be accessible, it should be interoperable and reusable. I think there is a link to the paper which initially defines this FAIR4RS. And this is, I think, basic knowledge research software engineers should get and gather. But this only looks into this FAIR thing, but we're looking especially also at the output of granted fundings. And there is also important, is it not only is the software well packaged, but also does it have an additional value for the community, for the scientific community. This is the scientific basis called, this is an additional dimension which was added here. Looks like whether the software follows common standards in the domain where it's bound, or how much does the software contribute to a research field. And then there is this technical basis, and this is, again, you can't evaluate the quality of a software without having these basic software quality indicators like complexity, test coverage, and stuff like this. And this is kind of captured in the technical basis. So does the software do what it actually means? And also, is there a process established that keeps the quality up to a good level? So these are the 3 tools that I want to mix into. And to do this, I want to dive into the indicators which we defined, or which are defined in the Helmholtz level. So it's like we have lots of indicators. I won't detail on every indicator, but I want to pick some examples and show how this could be automatically measured. So the first one is the dimension of findability. So here we see our 5 COBIT levels. And each level is defined or not. So this is something, number 5 is deleted. So we realized, okay, we have this COBIT model, but if you really force us to really put in software or an equivalent for every level, we end up with rather made of indicators or levels or quality in the quality criteria. That's what I'm searching for. So there are mostly only 4 levels defined, but they scatter about all these 5 COBIT maturity levels. So here we have our 5 levels. So it's always you have to finish the first level, and then you can achieve the second level. So this means if you have reached level 4, all the other 3 levels should be also implemented. We tried to define these indicators in a way that it's automatically, so that's really built up, but there are some cases where this is not easily done, and there are still also some cases where you can fake your level, especially if you want to automatically assess it. So this is still ongoing work that but I think we're on a good path to do this. So let's look at the first dimension, and the first criteria here is open publication repository, and this means for first step, the initial phase, the software is contained in an online repository, and this is something I think we could easily check because, for example, if you really want to use Hermes for this, Hermes is running in a continuous integration pipeline. This means you need to have a repository to run it at all. So this is implied when you use Hermes. The second step is then some kind of description is available, giving further information on the software in this repository, for example, a README file. And this is again a criteria which is easily checkable. You can have a list of example file names which are well received as documentation, or explicitly say there needs to be a README, and this can easily be checked, I think. So the next one is a structured metadata description. For example, following data site given for the software is in this repository. And this is a bit more complicated because it's more vaguely. For example, data site, but there are different other ideas. You can use RO-Crate, you can use CodeMeta, you can maybe also use Citation CFF or whatever. But the good thing is the goal of Hermes is really to collect all this metadata into one place. So if you run Hermes, you have a collated metadata set, and then you only have to check whether it contains everything. So with an additional custom policy which says which metadata should be available or which metadata format should be used, you can even get this criteria automatically checked. And then the fourth level here is the repository is listed in some overarching meta repository, for example, Helmholtz Research Software Directory, RE3 Data, or whatever. And this is again, if you publish it, you should link it back. And if you have linked it in your repository, then you can easily check where this software is published, whether this URL is valid, and then you have this done. So this is some, even when we look at the process, I think it's done can be done technically rather easily. Looking at the next one, which is the dimension of versioning, or the criteria of versioning, gets more complicated. So it's easy just to write a version and check it. So, but the criteria are a bit more complex here. So there is some kind of versioning for the software is easily checkable. Check whether there's a version, you're done. But the second is getting more complicated because it says software uses structured, for example, semantic versioning. And this is abstract. So, okay, we have some well-known, well-adapted versioning schemes like semantic versioning, calendar versioning. One can check against these and then have say, okay, our rules, at least one rule matched. That's okay. But again, it's more complicated here because you have to refine what you are looking at. Next one is even more complicated. There I'm still looking for solutions. Is that a description of the versioning scheme is available. So, okay, we know there are semanticversioning.org, there's calendarversioning.org. These are descriptive, but how do you check whether this is related to the software? So you need to kind of, again, some policy which says, okay, your software needs to have semantic versioning, and then you can automatically check it again. But this is, again, an input that we need in addition. The last one is, there is a documentation on release cycles for the software, and this is, again, most probably a text file. We are releasing MD or whatever, and this process, we can check whether the file is there, but at the level 4, I'm not satisfied if this file is there, because this is really high level, which should stand for high quality. And this is getting more complicated. So this is, for example, one of these indicators where we might try to change it so that it's more automatable, or we need to look for a solution that this level can be checked. So these are just two of the examples of the dimension of findability. Here is a nice table which states all these current state of the criteria. I won't go through all of them, but you can see there are lots of green fields, which mean, it's easily checkable. We can implement it in Hermes or with a tool that works on the output of Hermes. But there are still some yellow, which mean we need an additional input. We need some rules that define how these checks should be. And then there is this red one, which says, okay, this I'm not sure whether we can anytime implement it, but maybe we have a solution, but we'll see. I'll come to this in the end when I go to the Outlook. Then I'll have some example from the accessibility dimension, which the first one is access options, so the processual access, where you can retrieve the data. And the first one is the software source code or executable is provided, and this is, I think, again, trivial. If you run Hermes, the software is in a repository, you're fine. The second one is the source executables being provided include some documentation on how to install and use the software. And this is, again, documentation and most probably written in the README. This means you have to check for some files, but again, this is level 2. I think here it's okay if you really have some heuristic saying, okay, in the README there is a caption installing, getting started, or usage, and if you have this and there is some text in it, this could be fine. Get more complicated with the next level. Provided checks allowed to determine whether installation worked as being expected. And this is getting into testing, kind of. So smoke testing, running your code, installing your code on the continuous integration, looking if it's working or not. And looking if it's working or not is a complicated part here. You can make install, see if it's finished, exit code 0, okay. But after this, is it usable? And then you need to start the software. And there is more complex stuff being done here. We think we can still capture it, because if there is some test environment there which installs it, then we can capture the output. And maybe the tests need to be more complex, but I think we can then look into the CI pipeline, collect the results, and then we can evaluate this dimension, this criteria. Yeah, and then the next one is provided test cases, make sure the software provides correct results, which goes into direction of unit testing. Running unit tests on CI is also something I think most of you have done, and you can easily capture results. They are uploaded to GitHub to make shiny pages and stuff like this. You can capture this, but yeah, we have here a bit of the problem that we could measure, for example, the code coverage, which is an indicator how good the software is tested, but which is the critical value here, which percentage you have to reach for code coverage to say, okay, your code is well tested, or are there other policies? And again, this is, I say, yeah, at this time, we need a policy kind of which states what criteria or what is good testing of a software. And this is not something which we can provide for everybody. Hence, yeah, we need another stuff here. So again, I have a table for this dimension of accessibility. You see there are only 3 criteria here: access conditions for organizational purpose, which is pretty well checkable in our view. Then access options for processes, which is partly checkable. And then we have technical accessibility, run start, which is interesting because only the level 5 is automatically checkable. So whether there's an installable package available, for Python, for example, you look into the PyPy, there is a package, you reach this level, but the other 3 are not checkable, which makes this green box also a bit shaky here, because, as I stated before, you need to reach every sub-level before reaching the highest level. And if you only can test the highest level, we cannot be sure that there's a package deposited on some repository, but it doesn't do anything, or it's an empty package, or it's a dysfunctional package. So that's a bit complicated here. So for the other dimensions, I won't go into the depths, but just show you some tables here. The next one is interoperability. Here are only 2 criteria currently defined in the paper, which says about input and output formats, which is rather capturable if you put enough metadata into it. But the problem here is it also speaks about common formats or used formats in the domain, and this again requires some additional input. What are the well-accepted formats in the different scientific domains you're looking at? Yeah, and then we have the adaptability and flexibility of use, where I really having a headache because these criteria are very hard to check. So this is again where the human comes in, and you can't easily simulate the human with a computer and evaluate whether this is usable. Then we have the reusability domain, which is still very blank. So we just introduced the criteria of support, but we don't have any levels defined yet. And we have the reusability conditions, which are really well testable thanks to the reuse framework and the reuse tools. So this are looking forward to. Next one is the scientific basis. And the scientific basis, in the beginning I told you, it's about checking how the embedding in the scientific environment is. And the embedding in the scientific environment is a bit hard task. So you could mine papers for references, but it's also the criteria it's all about, or lots about people donating to this process and stuff like this. And yeah, it's really hard to identify an expert just by a pure software system. So this is really something we need to look into. And then we have the technical basis, which is a bit mixed, which kind of also shows the problem we are facing here. Quality indicators for software, the pure, so complexity, stuff like this, can be easily measured by tools, but can't be easily understood by managers. And here is the problem with the different levels we have to match. And this is reflected in this table. So there is also still some work to do. And there is lots of more, but here we also have this nice part where it's really more this, how good is the software quality itself, stuff which is hopefully easily checkable. So now I want to give you a short example to understand what we are checking and how we are checking. And for this, I made an example of our, it's a recap again, So not all criteria are automatically accessible, but we assume we have a graph, a complex graph of all the attributes and metadata about the software. And the strategy is to use Hermes to collect this data and then have a tool which checks this graph whether certain constraints are available and valid. And here we have a short example, an excerpt of our Hermes output for the Hermes software. Of course, we dog food ourselves. And you see here code meta in a JSON format. With some shorten, but I want to especially show 3 indicators that we had before. First one was whether there is a license assigned. And this is easily be checkable. You look whether there's a license and check whether the license applies to one of a list, or here especially Apache 2. And this is a Shackle expression. Shackle is a language which can be used to constrain graphs. So you have a expression, and this expression is checked against the graph, and then you can see, okay, it matches or not. And this is an expression which checks whether there is this Apache license. Similar to this, we have an expression which checks for semantic versioning. So we have a version attribute, and this version attribute can be evaluated with this Shackle expression, and this Shackle expression says good or not. And then we have here I added, so this is not yet done in the upstream Hermes version, but will be implemented soon. We can collect files which are related to the project and check whether there's a README, for example, also easily within Shackle expression. I haven't the expression here yet, but we have a test expression for this which is working. Well, and this is about what we want to do. And you see, we need to add more metadata. We need to see how these checks might be, and we need also to parameterize them. So it's like we say, okay, Apache license 2, but maybe the criterion is just an OSI approved license, and you would have to check against a list of items. And writing Shackle is, again, not something which is easily done for management. So we have lots of work to do, and luckily we have a software card project just started, and it's a dashboard for curation of metadata, for exploration of metrics of the software, and also for policy definition. That's what in our project plan stands. And yes, this is also the point where we want to look into how these policies can be easily done or templated or parameterized so that you can click together some policies for your special project or for your special funding, whatever. Yeah, so next step is, we are working to extend the metadata graph by adding additional metadata, which is a thing for Hermes. So if you want to get into touch with it, it might be a good idea to provide a harvester for additional metadata. And we would be happy if you join our project. Then we need to investigate which policies are there and should be implemented, provide examples for this, and also provide a baseline with some policies which can easily be adapted so that the people don't start from scratch, but have, for example, the Helmholtz criteria or something like this to work on. Yeah, and then the last thing is how to integrate this into existing environments, because we want to do it automatically, we want to run in the CI, and we have also this reportings, we have deposition platforms and stuff like this, and all this needs to get together and easily be done. And here's a little outlook. I promised some words about contents of text files. We are also thinking about whether LLMs or classificators or kind of artificial intelligence could be used to evaluate how the contents of a text file is. But this is just a rather new idea. We didn't investigate it, but if you want to exchange with me, I'm happy to talk about you with this. And that's the end of my talk, and I'm happy to answer your questions.
Thanks very much, Michael. I will just get Canopy up. And I think we've got our first question. So you mentioned technical accessibility. Could user accessibility, so colors, fonts, user flow of UI, be integrated into this?
This would be very interesting, yes. So I know there are frameworks which allow to evaluate the accessibility of the software. But again, these are criteria which are more human-made. So for humans to do checklists. But this is a good idea. We will definitely investigate into this. So thanks for the input. Yeah.
While we wait for more questions, you mentioned about people being able to kind of collaborate with you. Did you want to share more information as to how people can do that? Just get in touch with you?
Maybe the best thing is github.com/softwarepub. So this is a group I talked about, and there you can contact us. There you can find my contact details, or otherwise just michael.meine@dlr.de. Send me an email.
Brilliant.
Or talk to me here on the conference.
Yeah. So if funders would be using this, how do you prevent people gaming the system?
Yes, this is a good question. I think this is one of the strengths of the system, how they define these levels. They are not easily to be cheated because they look on the process and not on the output. But yeah, it's really a tough problem. The Helmholtz Association is going forward with defining these levels and doing a first round of indicator reporting. And they're currently discussing what the reported indicators should look like, whether it's an aggregator level or whatever. And this is especially investigated to avoid cheating. Yeah. But there will be cheaters, and that's why I think in the end there will be always somebody looking into the values in the results.
Thank you. Is there a way to integrate other tools like Snyk into software as an optional plugin, for example?
Yeah, so the Hermes software is plugin based, so we have this pipeline with the 6 steps, and every step can be extended by plugins. And it's easily, and we also have some first collaborations with other people integrating the tools into our workflow. So yeah, that's one of the design decisions there.
And when do you think open sourcing this tool?
It's open source. It's Apache 2.
Already.
So the Hermes tool. The software card tool is not even written. So the pictures you've seen were mock-ups. This is our first output. So that's how far we are with software card and the first checker rules. But we are developing open source, and we are developing in an open repository. So you might not be allowed to push, but you are definitely allowed to fork and to contribute.
Brilliant. And last question. This focused on more of the outwardly visible indicators of quality. Could additional measures of the code quality be included?
Yeah, sure. So this is something I really want to have into Hermes, that the software quality indicators are metadata and put into the metadata, and we are working for. Yeah.
Brilliant. Thank you, Michael.
Thank you.